It's a bit common sense needed. It says that a uniform table has a weight W, that's 100 Newton, and you definitely know where the weight acts in the center, and supported by the framework shown. So supported legs, it's on the legs, so it's like on the ground. Determine the smallest vertical force P that can be applied to a surface that will cause it to tip over. Interesting. It says here that I've got a table which has got a weight of 100 Newton acting in the center, and you need to find the smallest vertical force. Vertical force, that is basically in this direction, vertical force, okay? Vertical force that can apply on a surface that will cause it to tip over. So it should, the table should tip over. Interesting. Okay. So the only thing we know is that this is the 100 Newton force applied at the center. Because that's the weight. Now, my question is, let me put some forces. That's A, that's B, that's C, and this is it. If this is the same as B, so 3 forces are fine. Okay, so question, so A is not here. A is, come on. A is here, center. That's the A. Okay, so my first question is, I can apply forces at A, B, C. At which location the table will tip over? Will it tip over if I apply force at A or at B or at C? Think.
You need minimum force at point B.
B. Yes, it's common sense. You can clearly see that it's the B point. It's the edge. Okay, it is the edge. You have to apply force at the edge here. Also, here. Come on, here. What happened? Here, 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 or here. It's the same. Okay. So we now know we have to apply a force here. Okay. So it says, what is the smallest vertical force? What is the smallest vertical force to be applied here? Vertical, not horizontal, vertical force. What is the smallest vertical force we have to apply at this point to make it tip over? Interesting. Okay. Now, the turning moment. Do you agree with me that it will rotate or tip over along this line? Do you agree with me?
Yes, sir.
Yes, sir.
It's common sense. Okay. So we know it will tip over here. So it means visually you can see that the moment created by this force, vertical force of 100 Newton into this distance, if that is equal to my vertical force into this distance, it will be at the verge of tipping. Do you agree or not?
Yes, sir.
Anyone who didn't understand this point, please, as it's the time to shout. Yes, that means everyone knows. So again, remember.
Sir, can you repeat,
Yep.
please?
Okay. So we know that at this point, it will tip over. I have to apply force here. So when I apply force here, the table will swing, okay? And the point of swing will be this point and this point. Do you agree?
Yes, sir.
Okay, so I can draw a line here. So it will tip over along this line. Now, to visually see, let me okay. Now this point here, vertically down, lies somewhere here. Okay, so visually you can see that that's my force being applied at the center, multiplied by this distance. If that is equal to this force applied multiplied by its distance. You agree?
Yes, sir.
If both the moments are the same, then it's at the verge of tipping. Is that clear?
Yes, sir. It is clear now.
Okay, so I've done this on a piece of paper and then scanned it so that it's easy for me to explain. So let us now spend time here. I'm looking from the top. It's the top view, okay? So this G line is this line. Sorry, it's this line. That's my G. Okay, and P point is this point, P, which lies on the surface somewhere here, P. So that's my P point here. That is the edge of the table. And what I'm after, I'm after the moment that is this force into this distance and this force into this distance. I'm after that. So that I can equate both and I can get my P value out. So what I need, I know the force here is 100 Newton. I don't know D1 and D2. So I'm going to spend time on D1 and D2, how to find D1 and D2. Okay, so let me get rid of this because I've got the values written up. So I need distance D1 and D2. This distance, I've got this distance. That is the distance from the center to the line where it's going to tip over. How I got this distance? So let us see. Okay. Okay, let me. Okay. It's a perpendicular distance. You know that. Okay, it's a torque. I'm finding torque along the line. So it's a perpendicular distance. I know. I know this distance from here to here. That's given here. So I know the distance from here. So from here to here, that is given here. I've got the two distance. Knowing the two distance, and I know so I've got the two distance and it is 90 degree here. Knowing the two distance, can I get the angle out?
Yes, sir.
Can I?
Yes, sir.
Yes, sir.
Okay, so I've got the angle out. Okay, I've got the angle out here. Okay, I know this distance. Remember, this distance is known. Now the angle is also known, and this is my vertical distance. Can I now find this?
Yes, sir.
Yes, sir.
Yes.
Okay, so that's how I got my this distance out. So I've got my D1. Remember, I needed this distance from here. That's my D1. I found that. Now let's see how I'm going to find my D2. That's the other one. Okay, so I've got the angle here, which is the same as here. Remember?
Yes, sir.
Two parallel
Yes, sir.
lines cross, the angles are the same. Remember that?
Yes,
Okay.
sir.
So I've got the angle, same angle here. Okay. I know. Come on. I know my P distance, this distance, which is this divided by 2. Okay, half. I know that. Okay. How did I get this one? Hold on. I know the angle and I know, yes, I know this distance also. This distance is basically A by 2 minus F. You agree?
Sir, B by 2 minus F.
B, sorry. B by 2. Is that clear?
Yes, sir.
So I know this distance from here to here. This distance is B by 2 because the distance from here to here is B. So half B by 2 minus this F gives me this distance. So I know this distance. I know the angle. Can I get this out?
Yes, sir.
Okay, so I can get this out. So I've got it. So now I know this distance from here to here. That's the distance I know. I know the angle. I know it is 90 degree because when you distance, can I get this out?
Yes.
So what's left? That's it. Nothing is left. All you needed was the distance, and then you do sum of all the moments at the line, and you got your moment because of the weight, and you got the moment because of the force P, and you can get your force out. Is that clear to everyone?
Yes, sir.
Yes, sir.